And we've got s equals ut plus a half at squared, back to our original function. And now we know that u equals 0.03 because we've arrived at that using autograph, and we know that a equals 9.81. So now we're ready to go to the next part of the problem, which is to find how does the displacement, remember, vary with time. Now we can do it because we've got values for the constants u and a. So we can plot s equals u, which is 0.03, t plus 0.5 times 9.81 t squared. So that's the function we're going to plot now that we know what u and a are. For autograph, there's two things we need to do now. One is to work out what 0.5 times 9.81 is, and then the other thing is to assign y and x to s and t so we can plot them. Remember, t is the independent variable, so that's going to go on the x-axis, so t is going to be replaced with x, y is going to be the displacement on the y-axis, the one we plotted in other words. Now we know values. So if we go back to the function we plotted in the first place on autograph, we played around with it with u and a set as 1, remember. So you might find you want to plot just s equals or y equals u x plus a half as we've done here. But what we're going to do now is actually change this formula to the one we want to put in. So y equals u, which is 0.03, x plus 4.905, was it? X squared. So now we plot that and we get this function. Okay, so that's the one we're interested in. We're now plotting displacement against time for this particular scenario where u equals 0.03 and a equals 9.81. So again, if we're interested in this particular quadrant, we might want to zoom in on the x-axis so we can stretch out this curve. And now we can answer questions like, how far is this particular object that we're interested in going to go after 1 second? So we did an experiment, but now we have a way of predicting where this thing is going to be. So after 1 second, we can go up and across and say it looks like it's going to be around about 5 units of measurement, whatever we're measuring in. How long does it take this object to go a distance of 10 units of measurement across and down, and we can estimate what it is. And then to get the answer accurately, I can zoom in. So if I'm interested in this particular point, I'd zoom in on that part of the curve.